Propellant Engineering Division, and it was a unique experience. There was a sort of an experience in CSIR. So we had different kind of work culture, and in ISRO, I worked in Propellant Engineering Division to start with. I was actually recruited for doing the cryogenic engine development. So I did made a proposal for developing a cryogenic engine of 3.5 ton thrust engine, turbopump fed engine, and also 7.5 ton engine, which is similar to what was used in Atlas Center. Simultaneously, of course, by that time, unfortunately, Sarabhai passed away, and it ran into rough weather and got lost in the turbulence. So the cryogenic and semi-cryogenic work got stopped at the time in 71 after the death of Sarabhai. But afterwards, I started working on establishing what is required for solid propellant engineering. We need about 23 ingredients, out of which one of the major ingredient is ammonium perchlorate. How to produce ammonium perchlorate was a big question mark, and Electrochemical Research Institute at Karaikudi, they had done some work on how to convert sodium chloride into sodium perchlorate, and then we found out that by double decomposition we can do ammonium perchlorate. So for this we established an engineering cell. That means they were doing it in a laboratory test tube scale. So for doing it in an engineering scale, we established a big cell which can convert this sodium chloride into sodium perchlorate. So what happened was it needed a lot of electricity, and we did finally come to a conclusion that we could produce ammonium perchlorate required for meeting the propellant specifications. The ammonium perchlorate is not only required, it has to be produced in correct particle size, particle shape, and we have to sieve it out and then use the make a mixture of the ammonium perchlorate. So all this we did, and we have established based on the technology we developed, we have established a new facility near Halve, near Cochin, to produce about 300 tons of ammonium perchlorate per year. So we produce 10 different particle sizes, and we make a mixture to meet our requirements. Because these particle sizes are very important, because we have to control the burning rate of propellants. Without controlling the burning rate, solid propellant will be not so very useful. So we did this kind of job there, and then I switched over to liquid propellant, where in this one of the ingredient in solid propellant is toluene diisocyanate, which is 10 times more toxic than what the Bhopal tragedy took. We had to handle several kilograms of that in our laboratories and production place. We established a vertical mixer, because so far the technology was to do a horizontal mixing of all the 23 ingredients. We developed a new vertical mixer, and we got it done through CMTI here in Tumkur Road. One of my classmates was there in engineering design, and through his office and good offices, we got it done. And now we are using vertical mixers in Sriharikota production plant. Later on, I switched on to liquid propellant.